No sunshine. Alright, let's see this. It's a medium today. Maximum square area by removing fences from a field. There is a large m-1 by n-1 rectangular field with corners at 1, 1 and m and containing some horizontal and vertical fences given in arrays h fences and v fences respectively. Okay, this is very similar to yesterday's. Horizontal fences are from coordinates h fences, 1 to h fences at I, h fences at I, 1 to h fences at I, n. Okay, yeah, they span basically the length and the width of the field, or yeah. Return the maximum area of a square field that can be formed by removing some fences, possibly none, or -1 if it's possible to make a square field. Since the answer may be large, return it modulo 10 to the 9th plus 7. The field is surrounded by 2 horizontal fences from coordinates 1, 1 to 1n. Fences cannot be removed. Yeah, this is very similar to yesterday's. I'm wondering what's the difference between yesterday's and today's. So here, M4N3. So 4 means there's 4 rows. 3 means there's 3 verticals, columns. H fence is 2, 3 means you can remove 2 and 3, right? Can be removing some fences, possibly none. Okay, so you can remove 2 or you can remove 3. And vertical fences can remove 2. So here just remove the 2 horizontal and the 2 vertical. You return the largest maximum area square field. M6N7. Is it automatically filled in the middle? No, yes. So here it's not automatically filled. I think yesterday it was automatically kind of every horizontal and vertical was already there. Is that right? I think so. Here there's a fence at 2 and a fence at 4. So if you remove the 2 and 4, you get a 6 by 7. Is that right? No. 5 by 6. Yeah, you get 5 by 6. And then the other things work. Okay. And what is the thing here? The answer may be very large. Return modulo 10 to... Wow, really? Really? I guess maybe, okay, yeah, okay, sure. The bounds probably is really big. No? Yeah, the bounds can be really big. 10 to the 9th. Okay, let's go ahead and just say return some answer variable mod. Alright, so you have a bounded thing. You have the perimeter of the m by n. You have the perimeter of m by m. M here is the basically height, the number of rows, kind of, which corresponds to h fences to remove parts of it. So here we're just trying to find so 600 bars, vertical and horizontal. I mean, my inclination, we're trying to find the biggest matching gap, in both horizontal and vertical, I want to say. Does that make sense? So for instance, if I have 1, 2, 6, then the gaps could be 1 from 1 to 2, 4 from 2 to 6, and 5 from 1 to 6. So those are all kind of possible heights of the square. And then the length or width of the square could be 1 to 4, which is 3, 4 to 7, which is another 3, or 1 to 7, which is 6. And the biggest matching of the possible heights and the possible widths would be your square. This is actually what I was maybe thinking about at the very start of the last problem as to what they were trying to get me to do. And I thought when I heard that or interpreted it that it'd be pretty simple. Just finding that list of longest things. So if there's 600 horizontal placements, then I think if you go through each possible kind of combination of two horizontal bars as your top and bottom of your rectangle, then you get n squared-ish or n squared divided by 2 combinations. So 600 times 600 would be 36,000-ish. So like maybe 18,000 if I divide by 2. Oh boy, 180,000. Off by order of magnitude. And then you'd have to maybe sort them and then see the first one that matches between the vertical and horizontal. That's a lot. That is a lot. H fences and B fences are unique. I'm not sure what that means. 600 some combination. Is there another way to, so let's say M is 100 and let's say the H fences was some random, I don't know, let's go 2, 15, 21, 30, 35, 37, 41, 80, 90, something like that. It's 8-ish. So the gaps would be like 1 to 2, 1 to 15, 1 to 21, 1 to 30, 1 to 35, 1 to 37, 1 to 41, 1 to 80, 1 to 90, 1 to 100 as the possible kind of things that start with 1 and go to some bottom one. And then you have 2 to 15, 2 to 21, 2 to 30, 2 to 35. So could I how would I get all the combinations? Work through all the combinations. Work through all the combinations. Besides iterating over every single pair of places where the H fetches occur. One to 2, 1 to 15, 1 to 21, 1 to 30. 1 to 2 is 1. 2 to 15 is 13. 15 to 21 is 6. 21 to 30 is 9. And that's all at the first level. Hmm. 600. 600. I iterate over. Technically, even though they don't have it, I could add a 1 and 100 here. It's technically based on just the M being that. That implies that there's fences at those spots. If I do an iteration, pass through all the values, create a delta array, which is the length of the the difference between consecutive ones and H fences. So like the first delta, or let's say D level 1, first derivative kind of would be 1, 13, 6, 9, 5, 2, 4, 39, 10, 10. And then D2 would be, oh, what's going on here actually? What's going on here actually? The 1, I don't find the derivative of these, right? Maybe 13 plus 1 is 14, where 14 kind of represents 1 going to 15. And then 13 plus 6 would be 19. 19 represents 2 going to 21. 6 plus 9 is 15, which represents 15 going to 30. And then 14, 7, 6, 43, 49, 20. And then D3 would be 14 plus 19, 33. Right? What would that represent? Guess that's not what I really want. 33 doesn't really correspond to anything. I think I would want something like 1 to 21, which is 19, which is 20, which represents 14 plus 6. And then 19 plus 9 is 28, which is 2 to 30. I don't know if this is any good. Seems like a lot of junk. Seems like a whole lot of junk. Junkity, junkity, junk. How to find the maximum corresponding values. Maximum shared values. I mean, in theory, 1 to 100, which is 99, is going to be the largest square height, largest rectangular height. And then I could it seems vaguely familiar. Oh, Lord. very vaguely familiar. Uh, what was the problem that was similar to this? Seems so eerily familiar. It had something to do with prefix sums plus some sort of hash function. Some sort of hash, not hash function, but hash plus some sort of set. Some sort of set memory. How did it work? It's like trying to find, like you're given an array of values, and maybe it's something like similar to something like given array of values, find the largest difference that occurs twice, something like that. And you're supposed to use a prefix array, largest difference between consecutive values. Something like that. So if I did some sort of prefix sum here, the prefix array is going to be 1 plus 2 is 3 plus 15 is 18 plus 21 is... Does this work? I can't imagine this being the correct... Yes, h fences is or like the prefix. D1 1 to 100 is 99. So how would I maybe check to see if 99 is possible as the difference? Guess I can't do binary search, huh? Guess it has to be exactly. Don't think the binary search works. So if 99 occurs, how could I cross check to see if 99 works? What would be the speed of that? That would be pretty slow. There's 600 entries, like 160,000, 180,000 possible heights. Six hundred divided by 2. Iterate over. Could I use some sort of heap, or I don't think a heap would work. One be too large, really. 180,000 values in your set. That's a lot of values. There's some way to maybe order the differences somehow. 1, 2, 5, 1, 2, 15, 21. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values. So 11 times 10 divided by 11 times 12 divided by 2. So 11 times 6 is 20, 66 possible combinations, heights. That'd be too much to list. Okay, probably let's go ahead and do something smaller here. So let's say it's 30. So the differences, possible heights would be like 1 to 2 is 1, 2 to 15 is 13, 15 is 21 is 6, 21 to 30 is 9, and then going on to that 1 to 15 is 14, 2 to 21 is 19, 15 to 30 is 15, and then going 1 to 21 is 20, 2 to 30 is 28, and 1 to 30 is 29. Okay. So it's 5 values, 5 times 6 divided by 2. That's 5 times 4 divided by 2. So it's, okay, sure. So that composes all the possible heights. All the possible heights based on those horizontal fences. And then I would have to compare it to all the possible widths based on the vertical fences and see what's the largest overlap. I mean, is there another way that I could possibly do this? Would I make that into a set? Will I keep it in array and sort the array? Keep the array and sort the array. How much memory would 180,000 integers take? Would an array? Maybe that's actually not too bad. 20 megabytes. Okay. Alright, let's just go ahead and just try it. So it'd be for, what would the calculation be here? 1 to everything after it, 2 to everything after it, 15 to everything after it. So let's say hnum is equal to the length of h fences. Actually, let's go and just make a helper function here. Define get lengths, taking an array of integers, returning another array of integers. So I'll say, let's say the count is equal to, well, I guess I might also use n here. No, can't use n. Count is equal to length of this array for every index I in range of the count for every index. Okay, no, say j and k here. I don't like using I and j just because it looks so similar. For every k in range of I to I plus 1 to count. So it iterates over them. Let's do possible as my returning array. Possible appends. I want to add 1 and the length to this array. 1 and the length. I think I probably need to do something like is it possible an array or is it a set? Maybe I make this into a set actually. Because I don't care about duplicates. But I will convert that set into an assorted list. I think I want something like array appends. Actually, I probably need total as another int here. Appends the total and array appends 1 maybe. So adds, so if the original each parenthesis is just 2, 15, 21, it will be something like 2, 15, 21, 31. Is that right? Yeah. Wonder if I can do this with a list comprehension. Probably. Probably, but maybe it'd be faster actually. List comprehension. Okay, I think just the total is probably fine. I think the logic is just too tricky if I add 1 at the end. I'll say the set is that just initially it's going to be for every I in range count possible append array at I minus 1, which is the difference between that horizontal placement and the top 1. Initially add, since this is a set. Whoops. j plus 1 to count, possible to add array at k minus array at j. And then return, let's say the list plist is going to be the list based on list possible, and then plist.sort. I think I could just do something like sorted, right? Python sorted. Sorted is a built-in function, returns a new list based on iterable without modifying the original data. Okay. Yeah, I think I just need to be return sorted. Of the possible list. And then it should be something like h lengths are going to be get lengths of the h fences. V lengths is equal to get lengths of the v fences. And let's go just and print out those things. See if it works. Unterminated tri-quoted string literal. Whoopsie. Missing a positional. Oh, whoops. Yeah. This should be M. This should be N. I could also just append those to whatever. V length is not defined. Excellent, excellent. V lanes. Okay, so horizontally here it should be like 1, 2, and 3 are possible heights, and 1, 2 are possible widths. Okay, here it should be 1, 4, and 5. Yeah, and 3, 3, and 6. So 3, 6. Okay, so it looks fine. I think I maybe want this to be sorted in reverse. Is there a parameter for reverse equals true here? Reverse equals true. Okay, and then I just need to find the first one that matches. I guess it's going to be a double pointer kind of deal. Let's say I double pointer kind of deal. Here I think I can do h lengths append 0 just to have a dummy backstop. That will be the same for both. Okay, so I equals, or let's say h index equals v index equals 0. And then I'll say while h lengths at the h index not equal to v lengths at the v index, then iterate increase one of them, increase the index for one of them. If the h lengths at the h index is bigger than the v lengths at the v index, that means I have too big of an h, so I need to increment h because that'll decrease the height. And I think that should probably work. Okay, and then here I can say if the h lengths at the matching index equals 0, then return -1 because it means it didn't find anything that matched. else. Otherwise return h lengths at the h index squared and then to the mod. Guess I don't need parentheses here. This might be too slow. It's a lot of oh, it's n squared for sure. Oh boy. Oh, did I forget to sort? Yeah, I think I need to sort the arrays originally. Okay. Sometimes you're the head, sometimes you're a tail, sometimes you're the body. Today I am the tail. Okay. Not unexpected. It's definitely n squared. How to do this better? Like I mean, it's technically not that bad, to be honest. Doesn't seem like it's actually an order of magnitude or kind of a order of growth. Is that, what was that called again? Order of growth. Time complexity. What is the term there again? Okay, yes, order of growth. Yeah, it doesn't seem like it's an order of growth off. Like this thing, which is n squared, might still be over here, which is n squared, just maybe slower in things. If this was n squared and this was n log n, I'd be kind of surprised. Maybe. Not sure. It's definitely not. I'm pretty sure it's not like O of n squared here and this is O of n. O of n would be very fast. O of n would be very surprising if that could occur. But then how would you use sorting here? So is there a way to make this faster and keep it n squared? Or sorry, make a faster version of this n squared? So if I didn't keep the arrays, could I have done it in place? O of n squared in place? Like, what would happen if I had 29 to start with, which is 1 to 30. $29 to start with for 1 to 30. At that point, 29, which is 1 to 30, could go down to 20 if I go from, if I reduce the 30 by 9, going from 30 to 21. Or it can go to 28 if I go from 30, from 1 to 30 to 2 to 30. Is there a logic there? Always reducing, huh? It's always reducing. Kept a heap. Interesting. If I kept a heap, that heap would be too big. Spicy, spicy, spicy. Heap, heap, heap. Interesting. Huh. Huh, 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 huh. 1 to 30 is 29, and 29 somehow branches to 20 and 28 on the heap. Then 20, then at the top of the heap. 2 heaps, 2 heaps. I mean, I guess that might work. One to 30. 1 to 30 is 29. If I keep the 1, then it's 1 to 21. If I keep the 30, then it's 2 to 30. One to 30, 1 to 21, which is 20, 2 to 30, which is 28. But here, if I go 1 to 21, I could reduce it to 1 to 15, which is 14. Or I guess there's like a duplication somehow. Is the duplication like there's if I eventually get to something like 2 to 15, there's maybe multiple ways to get to 2 to 15. How many ways would there be to get to 2 to 15? How many times would that repeat? Interesting. Okay. Alright, I think it's time for reset. That way was as far as I can get that way. Wait, I'm gonna try this heap idea. Let's say that I have an H heap. This is my horizontal heap. Heap of it'll be the height for the horizontals. The horizontal form heights, and then I guess it should be indices. Should be indices or should be what I want to sort by. I guess indices or the actual values themselves is fine, which is easier. I need to go indices, right? Yeah, I need to go indices. And so A, B, A index or index 1, index 2. I think I need a set for that H set just to not have duplicates in my heap. And then I need to have the same thing for my vertical heap. It's going to be a heap of tuples that are, I guess it'd be the width, the index 1. This is the H index 1, H index 2. And this is the vertical index 1, vertical index 2. And I need a V set. Alright, starting off my heap, Do I really want to modify my H fences? Probably, huh? Guess I have to. I need to add 1 and M to it. I guess it should be just H fences equals 1 plus H fences plus M, something like that. I don't think it's, I think that might be kind of costly, to be honest. Yeah, 1, 2, 3, 4, and it's originally 1, 2, 2, 3. So B fences is equal to 1 plus B fences plus N. All right, my H heap should actually start with the tuple that is, I guess it'd be 1 to M, so the height would be M minus 1. Index would be 0. The other index would be what? The length of H fences minus 1. And then this one would be N minus 1, 0, length of V fences minus 1. Oh, whoops, this is going to crash. Okay. Okay. 1, 2, 3, go. I wanted to print out something here. So initially it's going to be 1 to 4. Oh, I need to sort them, don't I? I keep on forgetting to do that. H fences dot sort, V fences dot sort. So it should be the longest thing, which is 3, index 0 to index 3. And then the other one would be, longest thing would be 2, index 0 to index 2. Okay. Okay, so I wonder, should I put in dummy one? Probably not. Maybe. I don't know. While there is an H heap and there is a V heap and the top of the H, so while there is, if there isn't, then return -1, I think. Okay, while there is something at the top of each of the heaps, if it is something matching, so if H heap at 0, 0 is equal to V heap at 0, 0, which is perfect, then the side length is going to equal H heap at 0, 0, right? And then just return side times side mod, where mod is 10 to the 9th plus 7. Okay, so that's 1. Else if the top of the H heap has a length that is bigger than the v heap. So the length, the highest height is bigger than the largest possible width, and I need to break it up. Then I need to break it up. So I break it up and using indices. So let's say I pop, heap, pop. Let me just go ahead and just take it from the top actually. So let's say the height and h index 1, h index 2 is equal to h heap at 0. So there's going to be two tuples formed from this. So say kind of part 1 is going to be a tuple that is based on, I guess if the h index are if the h indexes are 1 apart, then I can't really go down to 0. So if the h index plus 1 equals the h index 2, then I just want to heap pop, remove the top of that heap, and skip. I guess I can just do else here. Else, this should be fine to make 2, I think. So for instance, if it goes 1 to 4, I can either go 1 to 3 or 2 to 4. 1 to 3 or 2 to 4. Um, 1 to 3 or 2 to 4. So part 1 is going to be the height should be h fences at h index 2 minus 1. This is a tuple to h fences at h index 1. That's the difference. And then h index 1 to h index 2 minus 1. Part 2 is going to be equal to h fences at h index 2 minus h fences at h index 1 plus 1. H index plus 1, h index 1 plus 1, h index 2. And then I need to check if either of these things has already occurred in the, if part 1 is in the h set, I guess if it's not in, then h set dot add part 1, and then I guess I need to do heap push multiple times, don't I? Yeah, just never mind then. Heap. I was gonna do heap push pop or heap pop push, but there might be 2 things that I need to add onto the heap for every 1 thing I remove, so it's not gonna really be efficient anyways. But in that case, this should just be if h index 1 not equal if h index 1 plus 1 not equal to h index 2. So hset.add this part1 and then heap or heap push part1. If part2 not in hset.add part2 heap push part2. Okay. I think that's right. Else, same thing but with the verticals. I wonder if I could do this using a helper function. Why can't I do this with a helper function? Okay, sure. Let's do a helper. Yeah, I can do this with a helper function. Define kind of process heap, I guess. I'll need to give the. I don't think I use a variable called heap. Use HP for heap. And I guess I need to do you pass in the heap and then pass in the set and you pass in the array. Heap set. It's a variable for the set. Man, I'm blanking out. H, S, and T for heap, set, and array. No. Set. Variable for set. I can call it set, can I? No, I just can't call that. That's ridiculous. P set, P heap, process set. Oh, I'll call the set scene. There we go. Heap, I'll call it HP. Guess heap is going to pass in a list. Scene is a set, and array is a list. I guess this should be a list of integers. What if I do a list of tuples? And this thing returns none. Okay, so I need to take the top of the heap off, or I need to peek. I guess I'll just need to take the top off in that case, right? Because this is actually peeking at the top and then just popping the top, so might as well just pop the top and take the return value from it. So I'll use length index 1 index 2 is equal to the heap pop this heap. If index 1 plus 1 not equal to index 2, then do this logic here. Part 1 is the tuple of the array at index 2 minus 1 minus array at index 1 to index 2 minus 1. Part 2 is equal to array at index 2 minus array at index 1, index 1, minus array at index 1 plus 1, index 1 plus 1, index 2. If part 1 not in the scene set, scene.add part 1 heap push onto the heap part 1 with part 2 not in scene, scene.add part 2, heap push onto the heap part 2. Okay, I think I can now just call the help function, process heap being here the horizontal heap, scene being the H set, and then the array is the H fences. This can be process heap, vertical set, vertical fences. That might be it. Let's see if this works. Okay. Cahoots. Okay. What's going on here? Expected 9, got 1. Interesting. 1, 2, 1, 4 is 9. 1 to 4 is 3. And then 1 to 4 is 3 as well. Huh, interesting. How did it not do that correctly? Okay, let's go and just print out the what I want to print out here. H fences, V fences, and then print out the H heap and the V heap. Oops, I probably need to use this as a test case. One two four one four five 302402. Those are exactly what I was hoping for. So it should have processed the 402. When I processed the 402, it should added 3, 301 and 1 112. Interesting. Alright, so let's go ahead and just add some calls here. Print H heap. Oh my god, I'm so stupid. I'm using a heap that is going to give me my smallest at the front, and I want to actually give it my largest at the front. Whoopsie. Okay, so heaps normally sort ascendingly. I need to sort descendingly, so I think I just need to make these values negative in order for it to work correctly. So this should be negative m plus 1, I guess. Yeah. So like heaps normally do like 1, 2, 3. 1 would be at the top of the heap. I want like 3 to be at the top of the heap, so I need to make 3 negative, 2 negative, 1 negative, and negative 3 is going to be top. Just need to be careful about that. So here it's going to be negative the source value of the tuple. And then here it should be less than. If this is less than, it'd be like -5 versus -2, and then this would mean that this is a bigger length. Okay. And then I need to make all these opposites, right? In order to make it negative, I can just reverse the order of subtraction. What the heck did I do? Okay. I think that's fine. I think that is fine. I guess I don't actually, since I'm multiplying a negative times a negative, it's going to be positive, so that's going to be fine. Okay, let's see if that works. Alright, well, that was a... Thank God I could recognize that error quickly. Oh my lord. Oh my gosh. Spent 30 minutes to improve it by 100 milliseconds. I'm actually kind of proud of the idea of a heap, but it's definitely not good enough. Huh. Not good enough. I wonder if it's the set that's slowing it down. You can deal without the set. Could I do it without the set? Maybe. Maybe. Oh well. Not like I have anything. Oops. Do, 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 do. Looking at the top one. Wonder if this is supposed to be like some sort of stack deal. So if I look at 1 to 15, 21, 30, 1 to 30 is 29, 29 splinters into 20 and 28. Could I do this with recursion somehow? Yeah. Recursion, it would have to be some sort of oh my god, it would have to be some sort of recursive stack. How would you do recursion here? Could you do recursion here? Do 130. Let's just think just a little harder here. 130, 121. Or 2 to 30. 121 gets you to 1 to 15 or 2 to 21. 2 to 30 would get to 2 to 21 or 15 to 30. Huh. 1 to 30 gets you 1 to 21 or 2 to 30. 1 to 21 gets you 1 to 15 or 2 to 21. Two to 30 gets you 2 to 21 or 15 to 30. Yeah, I don't know. Seems like you still want to keep track of all that. You use so much memory. Nah, I mean, what's a few megabytes between friends? Alright. It's too late for this. Okay. Summary. Tried, but both solutions I arrived at was relatively inefficient. Both solutions were based on determining all possible combinations of H and V values. Each combination gives a difference that is a possible height or width of the rectangle. Then try to find the largest common height width, which would make a square. In the above, use some complication heaps to determine how to find the next largest height width based on the indices that are involved. But it kind of sucks performance-wise. Yeah. Heaps. You start with the largest possible height, which is from index 0 to last index of your modified H array, where your H array adds in a 1 and an M to include the auto top and bottom fences. It's negative here because you want to sort by largest rather than smallest. And if you want, since it's ascendingly sorted, you want to convert your numbers to negative so that the largest is on top of the heap. Same deal for the vertical, and then kind of do an iterative process. If any heap empties, that means there's no comparison, that means there's not possible. If the top of the heaps are of the same lengths for those heights and widths, then just return the area of that square. And otherwise, if this height is actually bigger because it's more negative than the other one, then remove the height and kind of use this helper function to do that. Anytime you split a height from some two previous indices, then either it's going to keep the first index and decrement the second index, or increment the first index and keep the second index. And then there's going to be a scene set just to make sure that you don't repeat tuples, because it's possible to, with that kind of logic, to re-encounter certain indices with the pathing. Anyways, time complexity, this is going to be, again, O of n squared, since all possible kind of combinations of indices will be covered to determine the largest common one. There is some sorting that occurs, but that's O of n log n, and that's going to be faster than O of n squared, so O of n squared dominates. Sorting occurs, but since O of n log n is less than O of n squared, overall O of n squared. Base complexity is going to be O of, actually I think this might be O of n squared as well, since tuples will store kind of all combinations to be looked at.